Today we will explain Dijkstra's algorithm. A very useful algorithm with lots of applications. The explanation will be by working on this example. Nodes and edges represent a graph. This graph has the start node A. We will apply Dijkstra's algorithm on the start node A. We don't need at the moment to determine a destination node. Now let us set up the algorithm. Each node has two properties or variables. Best cost to this node from the source node A, and the previous node to this node. We will fill the nodes with colors to represent the status of the node. Blue for node we are visiting at the moment. Yellow for node is visited and we never visit again. White is the original state, which is unvisited node for now. When we see a red arrow that refer to a white node, that means the white node is unvisited node, and is reachable from the blue node we are visiting now. We set up the best cost of the source node to 0, and the previous node to itself. But that does not mean creating loops in the graph. Now let us start the algorithm from the start node A. It has three reachable unvisited nodes, B, C and D. For node B we compute the best cost of A, which is 0, plus the edge length that connects them, which is 10, equals 10. We compare it with the current value of the variable. If it's smaller we replace it with a new value. Now the current value is unknown, so we replace it with the value we got, 10. And because of replacing the best cost we should replace the previous node, which is here unknown, with the node we come from to reach this node B, which is A. The same for D. Compute the best cost of A, which is 0, plus the edge length that connects them, which is 22, equals 22. We compare it with the current value, which is unknown, so we replace it. And because of that we should replace the previous node, which is here unknown, with the node we come from to reach this node D, which is A. The same for C. Compute the best cost of A, which is 0, plus the edge length that connects them, which is 24, equals 24. We compare it with the current value, which is unknown, so we replace it. And because of that we should replace the previous node, which is here unknown, with the node we come from to reach this node C, which is A. We mark the node A with yellow as visited, and we never visit again. We select the next node to visit by taking the smallest value of the unvisited nodes. To get B, B has one unvisited reachable node, F. We compute the best cost of B plus the edge length that connects them, equals 35. The current value is unknown, so we replace it. Accordingly we replace the previous node value with the node we come from, which is B. Now we repeat the circle again. We change B to visited, mark it with yellow. Then we compare the best cost of the unvisited nodes, and we get D is the next node to visit. D has one unvisited reachable node, which is G. We compute the best cost of D, which is 22, plus the edge length that connects them, which is 3, equals 25. The current best cost value is unknown, so we replace it. And because of that we should replace the previous node value with the value D. Now we mark D as visited. We compare the best cost of the unvisited nodes. C has the smallest value, so we visit node C. Node C has one unvisited reachable node, node E. E has the best cost unknown, so we replace it with the value of the best cost of C, which is 24, plus the edge length that connects them, which is 7. equals 31. Accordingly we should replace the previous node, which is here unknown, with the node we come from to reach this node, which is C. Now we mark node C with yellow, and continue to visit G, because it has the smallest best cost of the unvisited nodes. From G we reach node I. We replace the best cost of it with the value 37, which is the best cost of G plus the edge Gi length, and replace the previous node value with the node G. Mark G as visited. Now we are visiting node E, and processing node H. The best cost of H is unknown. We replace it with 31 plus 10 equals 41. And the previous node variable will have the value C. Node E became visited. Visiting F. Processing I. We have processed node I before to get the best cost of 37. Now we need to compute the best cost of F plus the edge Fi length. To get 35 plus 17 equals 52. 37 is less than 52. So there is no need to replace the best cost value of node I. And we don't change the previous node. Node F marked yellow. Visiting node I at the moment. We don't have any node to process, because it has no reachable unvisited nodes. I marked as visited. Node H also has no reachable unvisited nodes. Now the algorithm stops, because all the nodes became visited. Now we got the best cost from the source node A to every node in the graph. And if we need the best path from the source node to any node in the graph, we should follow the previous node. For example, we considered the destination node is I. Node I has the previous node G. Then G has the previous node D. Then D has the previous node A. So the best path will be A, D, G, I. And the cost is the best cost of node I itself, 37. We can summarize the algorithm outcome with this table. Thanks for watching.